Hi, this is James Stambaugh. I'm making this video today to show you how my 24-105 lens is working. The zoom ring is sticking for me. So I've made some videos to display my issue that I'm having. I also have a 70-200 which is working just fine, and I've also will be including video made with that to kind of compare and contrast the two lenses. We'll also be trying to put a number to this, so kind of measure the torque that's required to turn the zoom ring for each lens. So that way you can see in numbers the issue that I'm having. This is the 70-200. So I'll zoom out from 70 to 200. Now I'll zoom in backwards from 200 to 70. This is the 24-105. So I'll zoom out from 24 to 105. And I'll zoom in. So we're going to measure the problem I'm having today with my lens so that you can more clearly see what's going on. We're going to use torque to measure that. So according to Google, torque is a measurement of the force which would cause an object to rotate about an axis. So that's exactly what we want to do with our lens. And if I can just show this simple diagram here, if I can get it on the center. So there's our lens in the center, and the radius will be from the center of the lens out to the point where we will hang some weight for measurement, and we will measure how much weight it takes at a particular distance to calculate torque. I'm sure most of you have heard of a torque wrench used in the automotive world. It measures in pound-feet. Since we're not working on a car today, we're working on a lens. We're going to switch units of measurement to grams and millimeters. So the result will be the same, we're just going to use a different unit of measure. So to help us measure the torque, I've bought one of these little focusing rings that you clamp onto the lens, and you can then adjust this, help to focus. It has a little hole in it, and I've created a little scales here that will hook into the hole, and then we will see how much weight is required to start the rotation of the zoom ring. We'll test the torque required to turn the zoom ring on the 70-200. It's obviously the white lens. We'll show it here. 70-200. starting to move. I'll zero out the scales. Oops. That's 0. And that takes 141 grams. We'll test the torque required to turn the zoom ring on the 24 to 105 lens. So there it moved. So we'll now put this on the scale. I'll turn the scale on and zero it out. So 0 grams. Takes 418 grams. So in order to calculate the torque, we need the force times the radius. So for each lens, we already have the force which we measured in a previous video. So now we need the radius for both. So the radius would be from the center of the lens to the point where the weight is hanging, this hole in the handle. So we'll measure the diameter and divide by 2 to get the radius, and then I'll add the length of the handle. So first I'll measure the length of the handle. Going to be something close to 59.04. So let me mark that down. So this is for the 24 to 105. I'll mark the handle length, 59.04. And on this one also 9.04. So those are both added in there now. Now I'll measure the diameter of the 24 to 105 lens. at the zoom ring position. So I'll put this in here. That is 80.98 for the 24 to 105. (24 to 105), 80.98, 98. These are all millimeters. If I divide that by 2, 80.98 divided by 2, 40.49 is the radius. So now if I add these two, the 40.49 plus the 59.04, so I'll add 59.04, 99.53 millimeters is the total radius for the 24 to 105. 9.53 millimeters. So I'll put this now on the total sheet here, 99.53. All right. Now I'll measure the diameter of the 70 to 200 at the zoom ring. So that is 79.11. I'll put that on this paper. 79.11. And if I divide that by 2, 79.11 divided by 2, 39.56. 6. And then I'll add the 59.04 plus 59.04. The total is 98.6. .6 millimeters is the total radius for the 70 to 200. So I'll add that on the total page over here. 98.6. 8.6. So now if I do the calculation, force times radius, so for the 70 to 200, it's 98.6 times 141. So I'll take that number we had before, times 141 equals 13,902. So this will be, trying to get this in here, torque equals 13,902. And that is gram millimeters. For the 24 to 105, it's 418 times 99.53. So 418 times 99.53 equals equals 41,604. T equals 41,604 grams millimeters. Okay, I'm just going to do a quick calculation here. I'm going to divide that by the smaller one. Oops. 41,604 divided by 13,902. 2.99 goes in 2.99 times, so 3 times. Just a quick review then on the 2 Canon lenses that I have, the 70-200 and the 24-105. The 70-200 works just fine. I don't have any problems at all. It's the 24-105 with the zoom ring. It's sticking for me, and hopefully I've shown that today. I've tried to measure it for you. It's 13,900 gram millimeters for the 70-200 and 41,600 for the 24-105. So this one takes 3 times as much effort to turn this zoom ring than does the 70-200. So I'm just asking you guys to take another look at this and help me out. So it's very difficult to use. Thanks and have a good day.